Right now, about 250 miles above your head, 6 human beings are living in space. They're floating through corridors the size of a 6-bedroom house, conducting experiments, eating rehydrated food, and watching 16 sunrises every single day. They've been up there continuously, without a single gap since the year 2000. This is the International Space Station. And the story of how it got there is wilder than most people realize. It starts not with cooperation, but with competition. The Cold War turned space into a battlefield without weapons. The US and the Soviet Union were both terrified of falling behind, and both were pouring money into anything that could prove their system was superior. Rockets, satellites, moon landings, space stations. The Soviets got there first. In 1971, they launched Salyut-1, the world's first space station. It was small, cramped, and its first crew died on the way back to Earth when a ventilation valve failed. But it worked, and it proved that humans could live and operate in orbit for extended periods. The Americans responded with Skylab in 1973. Bigger than anything the Soviets had built, it hosted 3 crews and produced a mountain of scientific data before NASA abandoned it in 1974. In 1979, with nobody left to maintain it, Skylab tumbled out of orbit and broke apart over Australia. Pieces rained down on the town of Esperance. The local council fined NASA $200 for littering. NASA paid it 40 years later. Meanwhile, the Soviets kept building. Their Mir space station launched in 1986 and became a symbol of endurance. It stayed in orbit for 15 years, hosting dozens of cosmonauts and surviving equipment failures, a fire, and a collision with an unmanned cargo ship. Mir was proof that long-duration spaceflight was possible. It was also proof that it was brutally hard. By the late 1980s, something remarkable started happening. The Cold War was ending, and with it, the logic of competing in space started to collapse. Space stations are extraordinarily expensive. They require constant resupply, constant maintenance, and more personnel than any one nation could comfortably sustain on its own. NASA had been drawing up plans for a large modular station since the early 1980s. President Reagan formally announced it in 1984, calling it Space Station Freedom. It went through years of redesigns, budget fights, and political battles. At various points, Congress came within a single vote of canceling it entirely. Then the Soviet Union collapsed, and suddenly, the calculation changed completely. Russia had the most experience of any nation on Earth in building and operating space stations. They had the engineers, the hardware, and the know-how. The United States had the funding. Bringing them together wasn't just politically symbolic, it was genuinely practical. In 1993, the Clinton administration invited Russia to join the project. Space Station Freedom became the International Space Station. Canada, Japan, and the European Space Agency joined as well. 15 nations in total. Former Cold War enemies now sharing the same oxygen supply. Construction began in 1998. The first module, Zarya, funded by the US but built and launched by Russia, lifted off on November 20th. 2 weeks later, the American Unity node was carried up by the Space Shuttle Endeavour and attached. 2 pieces of a puzzle that would take 13 years to complete. What followed was one of the most complex construction projects in human history. Over 40 assembly flights, hundreds of spacewalks, modules built in different countries, speaking different languages, designed to bolt together perfectly, 250 miles above the Earth. It didn't always go smoothly. There were delays, technical problems, budget overruns, and moments where the entire program looked like it might unravel. The Columbia disaster in 2003 grounded the shuttle fleet for over 2 years and nearly halted construction entirely. Russia's Soyuz spacecraft kept the station crewed during that period, a quiet reminder of why international partnership mattered. The station grew piece by piece. Solar arrays the size of football fields were unfolded in the vacuum of space. Robotic arms were mounted to the outside. laboratory modules arrived from Japan and Europe. Each new addition made the structure more capable, more livable, and more astonishing. On November 2, 2000, American Bill Shepard and Russian cosmonauts Yuri Gudzenko and Sergei Krikalev became the first crew to live aboard the ISS. They called themselves Expedition 1. Since that day, the station has been continuously inhabited, not a single day without humans on board. For over 2 decades, someone has always been home. Life on the ISS is genuinely strange. Astronauts sleep in tiny cabins strapped into sleeping bags to keep from floating away. They exercise 2 hours every day because without gravity, muscles and bones deteriorate fast. Showers don't exist. They use rinseless shampoo and wet wipes. Water is so precious that they recycle everything, including, there's no delicate way to say this, their own urine. The recycling system turns it back into drinking water with a purity that actually exceeds most municipal supplies on Earth. But the science happening up there is unlike anything possible on the ground. Experiments in microgravity have produced breakthroughs in medicine, materials science, and biology. Protein crystals grown in space form more perfectly than on Earth, leading to better drug designs. Flame burns differently in microgravity, cleaner, more efficient, and studying it has improved combustion engine technology. Observations from the cupola window have tracked hurricanes, wildfires, and the slow creep of climate change with unmatched clarity. The station wasn't built to last forever. Its original design life was 15 years. It's now well past that, and NASA has extended operations through at least 2030. The hardware is aging. Cracks have appeared in some Russian modules. Cooling systems have needed urgent repairs. Air has been found leaking from joints that have been expanding and contracting through thousands of temperature cycles. At the same time, the geopolitical situation that made the ISS possible has changed dramatically. Russia's invasion of Ukraine in 2022 triggered sanctions and strained the partnership that had held for nearly 3 decades. There were public threats from Russian officials to abandon the station. So far, cooperation has continued. But the fragility of the arrangement is no longer theoretical. The plan, for now, is a controlled deorbit sometime around 2030. The station will be guided back into Earth's atmosphere, and most of it will burn up on re-entry. Whatever survives will splash down in a remote stretch of the South Pacific Ocean. A structure the size of a football field, built over 13 years by 15 nations, will come home in fire. What replaces it is already being planned. NASA is working with private companies to develop commercial space stations that could be operational before the ISS comes down. The vision is a future where low Earth orbit is routine, where research, manufacturing, and eventually tourism happen in space, the way they happen in any industrial zone on Earth. It sounds ambitious, but so did the idea of 15 nations building a house in space together. And they pulled that off. If you enjoyed this one, hit subscribe. More stories like this are coming.